Hello, math learners! Our lesson for today is about ellipse as conic section. The learning objectives are: you are going to define an ellipse and its parts, determine the standard form of the equation of an ellipse, convert the general equation to standard equation of an ellipse and vice versa, sketch the ellipse, and solve real-life problems involving ellipse. This is the Learning Pocket Concept Map. Under ellipse, we have to discuss the forms of equations, parts of ellipse, the graph, and its applications. Let us have ellipse as conic section. Ellipse is a closed type of conic section, a plane curve tracing the intersection of a cone with a plane. This is the illustration. You have the cone, the plane intersecting the cone, and this figure is what we call the ellipse. An ellipse is the set of points in a plane such that the sum of the distances from two fixed points in a plane stays constant. In this illustration, the distance from the center to the vertex is represented by A. From the center to the focus is represented by C. From the center to the co-vertex is represented by B. And when you add the distances of D1 and D2, it is equivalent to 2A. Let us have the parts of an ellipse. The 2 points are each called a focus. The plural form of focus is foci. So this is the first focus and this is the second focus. The midpoint of the segment joining the foci is called the center of the ellipse. This is the center of the ellipse. An ellipse has 2 axes of symmetry. The longer one is called the major axis and the shorter one is called the minor axis. The 2 axes intersect at the center of the ellipse. This is the minor axis. This is the major axis. The endpoints of the major axis are each called vertex, and the endpoints of the minor axis are each called co-vertex. This endpoint of the major axis and another endpoint, they're what we call the vertices. And the endpoints of the minor axis, this is the first co-vertex and another co-vertex. A is the distance from the center to the vertex. B is the distance from the center to the co-vertex. And C is the distance from the center to the focus. And to solve for C, we have to observe this formula. C squared is equal to A squared minus B squared. Or C is equal to the square root of A squared minus B squared. Now, how to draw an ellipse? Let us have the steps in drawing an ellipse using the string method. Step 1, you have to draw the minor and the major axis. Step 2, you have to put a pin in each vertex, here and here, and tie a string to them so that the string between them is taut, and the string has the same length with the major axis after it is tied. Locate the foci and mark each with F1 and F2. So the length of the string is equivalent to the length of the major axis. You can mark F1 here and this is the location of F2. For step 3, leaving the string attached, move the pins to the foci or focus points, the F1 and F2. Then put a pencil point against the string and pull the string or stretch tight with the pencil. So transferring the pin here to F1 and to F2, you have to stretch the string. And then number 4, keeping the string taut, move the pencil in a large arc. The pencil will draw out the desired ellipse. To avoid the string catching on the pins, you may find it better to draw the upper half and the lower half of the ellipse separately. And 5, the ellipse will pass through the 4 initial points defining the ends of the major and minor axis. The ellipse has a desired width and height. Or you can do this way. The length of the blue string is equivalent to the length of the major axis. Then stretch it out and you can do like this. And you have now your ellipse. Let us have the general form and the standard form of ellipse. For center 0, 0, the major axis is x-axis. The general form is ax squared plus cy plus f is equal to 0, where a is less than c. The standard form is x squared over a squared plus y squared over b squared is equal to 1, where a is greater than b. For center 0, 0 with major axis to the y-axis, the general form is ax squared plus cy squared plus f is equal to 0, where a is greater than c. And the standard form is x squared over b squared plus y squared over a squared is equal to 1, where a is greater than b. And for center hk, where major axis is the x-axis, the general form is ax squared plus cy squared plus dx plus ey plus f is equal to 0, where a is less than c. And the standard form is the square of x minus h over a squared plus the square of y minus k over b squared is equal to 1, where a is greater than b. And for center hk, the major axis is y-axis. And the general form is ax squared plus cy squared plus dx plus ey plus f is equal to 0, where a is greater than c. And the standard form is the square of x minus h over b squared plus the square of y minus k over a squared is equal to 1, where a is greater than b. Let us have an example. Convert the equation into standard form. The given equation is 9x squared plus 8y squared equals 72. Divide both sides of the equation by 72. So you have 9x squared over 72, 8y squared over 72 equals 72 over 72. Then 9 with 72 equals 8. 8 with 72, it's 9. 72 with 72 is 1. So you have now x squared over 8 plus y squared over 9 equals 1. And this is the standard form of an ellipse. Given 9x squared plus 8y squared equals 72. Next example. Convert the equation in general form to standard form. The given is 3x squared plus 4y squared plus 24x minus 16y plus 52 equals 0. So the solutions, you have to regroup the terms. Group with the x variable. So you have 3x squared plus 24x plus with the y variable 4y squared minus 16y plus 52. Then apply common monomial factoring. The common factor of 3 and 24 is 3. Take out 3. So 3x squared divided by 3 is x squared. 24x divided by 3 is 8x. Common factor of 4 and 16 is 4. Take out 4. So 4y squared divided by 4 is y squared. Negative 16. Y divided by 4 is negative 4y. And transpose 52, that is equivalent to negative 52. Then you have to complete the square. So in completing the square, take the half of 8, and that is 4. Square 4 is 16. So the third term of the trinomial is 16. Then here, take the half of 4, it's 2. Square 2, it's 4. So the third term of the trinomial here is 4. And do not forget to add also to the right side. Since you are adding 16 here with a multiplier of 3, you add also 3 times 16. And here you have 4 with a multiplier of 4. You also add 4 times 4. So simplify. On this side, you have 3 times 16 is 48. 4 times 4 is 16. And simplify further. Negative 52 plus 48 plus 16 equals 12. And then you can factor x squared plus 8x plus 16 into x plus 4 times the quantity x plus 4. Factor y squared minus 4y plus 4 into y minus 2 times the quantity y minus 2 equals 12. And then express the binomial factors as square of binomial. This 2 can be written as the square of x plus 4, and this 2 can be written as the square of y minus 2 equals 12. And you have to divide both sides by 12. So 3 with 12 is 4. 4 with 12, you have 3. 12 divided by 12 is 1. Now after simplifying, the number here is already 1. And this is now the standard form of ellipse where center is HK. The square of x plus 4 over 4 plus the square of y minus 2 over 3 is equal to 1. Next example. Convert the equation in standard form to general form. This is the given x squared over 8 plus y squared over 9 equals 1. You have to multiply each member by the LCD of 8 and 9. And that is 72. So simplify, this is 72 times x squared over 8 plus 72 times y squared over 9 is equal to 1 times 72. And 72 divided by 8 is 9. 72 divided by 9 is 8. 1 times 72 is 72. Transpose 72, you have negative 72, equate it to 0. So the general form is 9x squared plus 8y squared minus 72 is equal to 0. Let us have example number 4. Convert the equation in standard form to general form. The given is the square of x plus 4 over 4 plus the square of y minus 2 over 3 is equal to 1. And you have to multiply with the LCD of 4 and 3, so that is 12. So you have to simplify. 12 by 4 is 3, 12 by 3 is 4. So what we have is 3 times the square of x plus 4 plus the square of y minus 2. And you have 4 here as the result of 12 divided by 3. And 1 times 12 is 12. Then expand the square of binomial. So the square of x plus 4 is x squared plus 8x plus 16. The square of y minus 2 is y squared minus 4y plus 4 equals 12. And apply distributive property. So what we have, 3 times x squared is 3x squared, 3 times 8x is 24x, and 3 times 16 is 48. Here, 4 times y squared is 4y squared, 4 times negative 4y is negative 16y, 4 times 4 is 16, and copy 12. So equate this into 0 and combine like terms, you have to transpose 12. So what we have is 3x squared plus 4y squared plus 24x minus 16y plus 48 plus 16 minus 12 is equal to 0. And combine, so you have 52. So the general form is 3x squared plus 4y squared plus 24x minus 16y plus 52 equals 0. Next, let us have ellipse with center at the origin, or what we call the horizontal ellipse. For the center 0, 0, the equation is x squared over a squared plus y squared over b squared equals 1, where a is greater than b. And to solve for c, we have the square root of a squared minus b squared. For the vertices, we have 2, positive a 0 and negative a 0. For the foci, we also have 2, positive c0 and negative c0. For the major axis, the equation is y is equal to 0. The location is on the x-axis. The length is equivalent to 2a. And the endpoints, we have the positive a 0 and negative a 0. For the minor axis, the equation is x is equal to 0. The location is on the y-axis. The length is equivalent to 2b. The endpoints, we have 0 positive b and 0 negative b. For the intercepts, we have positive and negative a. For the y-intercepts, we have positive and negative b. For directrices, the equation is x is equal to positive or negative a squared over c. The latus rectum, or in plural form, latera recta, the equation is x is equal to positive or negative c. Direction is vertical. The length of the latus rectum is 2b squared over a. The endpoints are negative c plus or minus b squared over a and c plus or minus b squared over a. For the eccentricity, the formula is E equals c over a. And this is the illustration of the horizontal ellipse with center 0, 0. This is the center, this is the focus, this is the vertex, another focus here, another vertex. This is the co-vertex, another co-vertex. This segmented line is the directrix. Another directrix is here. This is the latus rectum. And these 2 points are the endpoints of the latus rectum. We have another latus rectum. And these are the endpoints of the latus rectum. Take note, the focal axis or the major axis always contains the foci, the vertices, and the center. The chord of the ellipse through its one focus and perpendicular to the major axis or parallel to the directrix is called the latus rectum of the ellipse, and the plural form is latera recta. The rectrix of the ellipse is a fixed straight line outside the ellipse, and the plural form is directrices. The eccentricity of an ellipse is the measure of how nearly circular the ellipse. Eccentricity is found by following the formula eccentricity is equal to c over a, where c is the distance from the center to the focus of the ellipse. A is the distance from the center to a vertex. Let us have the ellipse with center at the origin, which is the vertical ellipse. The equation is x squared over b squared plus y squared over a squared equals 1, where a is greater than b, and c is equal to the square root of a squared minus b squared. The vertices, we have the coordinates 0, positive, negative a. Foci, we have 0, positive, negative c. For the major axis, equation now is x is equal to 0. Location on the y-axis, the length is equivalent to 2a. The endpoints, we have 0, positive, negative a. For the minor axis, we have equation y is equal to 0. Location on the x-axis, the length of the minor axis is equivalent to 2b, and the endpoints, we have positive, negative b, 0. The x-intercepts, we have the positive, negative b. The y-intercepts, we have positive, negative a. Directrices, the equation is y is equal to positive, negative a squared over c. The equation of the latus rectum is y is equal to positive c and y is equal to negative c. The direction is horizontal. The length is 2b squared over a. The endpoints are with coordinates positive, negative b squared over a and negative c, and positive, negative b squared over a with c as the y coordinate. For the eccentricity, E is equal to C over A. And this is the illustration. So by this time, the major axis is on the y-axis. And the minor axis is on the x-axis. This is the center, this is the focus, the vertex, another focus, another vertex. This is the co-vertex, another co-vertex. And this is now the latus rectum, which is horizontal. Another latus rectum, which is also horizontal. This is now the directrix, another directrix. Let us have an example. Find the coordinates of the foci and vertices, the endpoints of the major axis, minor axis, and the latus rectum and other parts and characteristics of the ellipse. Given 4x squared plus 9y squared equals 144. And you have to draw the ellipse. Given 4x squared plus 9y squared is equal to 144, you have to divide both sides of the equation by 144. So dividing by 144, we have 4x squared over 144 plus 9y squared over 144 is equal to 144 over 144. And by this time, 144 by 4 is 36. 144 by 9 is 16 is equal to 1. So you have now the standard equation of ellipse. And with this, you will be able to identify the value of A, which is 6, the value of B, which is 4, and solving for the value of C, all you have to do is to substitute 6 to A and 4 to B. So the square root of 20 is equivalent to 4.47. So identifying the vertices, so all you have to do is to substitute the value of A, which is 6. And the first vertex is with coordinates 6, 0, and the other one is negative 6, 0. For the co-vertices, we have 0 as the abscissa, and then positive B for the first y coordinate, and negative B, so negative 4 as the second coordinate. For the foci, we have 4.47, that's the value of C, 0, and the other one is negative 4.470. The equation is y is equal to 0, location on the x-axis, and the length of the major axis is 12 units because that is 2a, and 2 times 6 is 12. And the endpoints of the major axis are simply equivalent to the vertices. We have 6, 0 and negative 6, 0. For the minor axis, the equation is x is equal to 0, which is on the y-axis. And the length of the minor axis is 8 units, that is 2 times b. And b is 4, so 2 times 4 is 8. The endpoints is 0, positive, negative b, so we have 0, 4, and 0, negative 4. For the x-intercept, we have positive, negative a. So, positive, negative 6 is the answer. For the y-intercept, positive, negative 4. For the directrices, you just simply square A and then divide it by C. So the first directrix has an equation of 8.05. And the second directrix has an equation equivalent to x is equal to negative 8.05. The latus rectum equation, the first one, we have x is equal to negative 4.47. And the other one is x is equal to 4.47. Direction is vertical. And the length of the latus rectum is 5.33. All you have to do is to substitute the value of b and value of a. So this is 2 times the square of 4 over 6. And it will give you a result of 5.33. And for the endpoints of the latera recta, we have negative 4.47 and 2.67. Then we have negative 4.47 and negative 2.67. 4.47 with 2.67 and 4.47 with negative 2.67. All you have to do is to substitute the values of A, B, and C to this formula. And for the eccentricity, the value is between 0 and 1, and that is C over A. C is 4.47 over A, which is 6. So the value of the eccentricity is 0.75. So you watch this video for the graph. First, you have the major axis, then draw the minor axis, then the center. You have the first focus, then you have the other focus, the vertex, another vertex, then you have the co-vertex, another co-vertex, then the endpoint of the latus rectum, another endpoint on the other side, another endpoint, and another endpoint of the latus rectum. You draw a segmented line to represent the latus rectum, and then draw the directrix, another directrix, and then draw the ellipse. So this is the graph, and then you have to label properly the graph. The equation is x squared over 36 plus y squared over 16. This is the latus rectum with the equation x is equal to negative 4.47. The other one is x is equal to 4.47. The directrix here, the equation is 8.05. Here, negative 8.05. You have the vertex, focus, center, focus, vertex, the co-vertex, and the endpoints of the latus rectum. Next example. Find the coordinates of the foci and vertices, the endpoints of the major axis, the minor axis, and the latus rectum, and the other parts and characteristics of the ellipse x squared over 9 plus y squared over 25 is equal to 1, where A is greater than B. And you have to draw the ellipse. This is the standard equation, so the center is with coordinate 0, 0. The vertices, we have 0, 5 and 0, negative 5, because the value of A is 5. So by this time, C is 4. That's 25. Whichever the greater denominator, that's the value of your A squared. And take the square root, that's the value of your A. So A is equal to 5, B is equal to 3, and C is equal to 4. Because the square root of 16 is 4. And identifying the vertices, so we have 0, positive 5, and 0, negative 5. For the foci, 0, positive 4, and 0, negative 4. Major axis is x is equal to 0. The location is the y-axis. The length is 10 units, and the endpoints is 0, positive 5, and 0, negative 5. For the minor axis, y is equal to 0, and the location is on the x-axis. The length is 6 units, and the endpoints we have positive 3, 0, and negative 3, 0. For the x-intercepts, we have positive 3 and negative 3. For the y-intercepts, we have positive 5 and negative 5. For the directrix or directrices, we have y is equal to positive 6.25 and y is equal to negative 6.25. For the latus rectum, we have positive and negative 4. Direction, it's horizontal. The length of the latus rectum is 3.6 units. The endpoints, we have positive negative 1.84 and positive negative 1.8, negative 4. Eccentricity is 0.8. And this is the graph. So you have 0, 0, co-vertices 3, 0, negative 3, 0. The co-vertices are simply the endpoints of the minor axis. Then you have the major axis here. So we have the endpoints. This is the first vertex, second vertex. So the vertices are simply the endpoints of the major axis. You have here the endpoints of the latus rectum, and the latus rectum is y is equal to 4. Here y is equal to negative 4. Directrix, you have y is equal to 6.25. Here negative 6.25. And these are the endpoints of the latus rectum. Next. Since the denominator of y squared is greater than the denominator of x squared, the major axis is the y-axis. Let us have the standard form of the equation of an ellipse with center HK. First, let us have the horizontal ellipse. For center HK, the ellipse with foci on a line parallel to the x-axis, that is the horizontal ellipse, the equation is the square of x minus h over a squared plus the square of y minus k over b squared equals 1, where a is greater than b. And the value of c can be taken by using this formula, the square root of a squared minus b squared. For the vertices, we have h plus or minus a k. For the foci, you have h plus or minus c k. For the major axis, y is equal to k as the equation. Location is horizontal. The length is the same, 2a. The endpoints, we have h plus or minus a k. So it is the same as the coordinates of the vertices. For the minor axis, equation is x equals h. Location is vertical. The length is also 2b. And the endpoints, we have h and k plus or minus b, or simply the endpoints of the co-vertices. For the latus rectum, equation x is equal to h plus c and x is equal to h minus c. Direction is vertical. The length is 2b squared over a. The endpoints of the latus rectum, we have h minus c and k plus or minus b squared over a. And h plus c with k plus or minus b squared over a. Eccentricity is still c over a, where e is between 0 and 1. Directrices equation is x is equal to h plus or minus a squared over c. And this is the graph of an ellipse where the center is not at the origin. This is the center, focus, the vertex, another focus, another vertex, endpoints of the latus rectum, the endpoints of the latus rectum. You have the co-vertices, you have the vertices as the endpoints of the major axis, and you have the directrices. Let us have the vertical ellipse with center HK. The equation is the square of x minus h over b squared plus the square of y minus k over a squared equals 1, where a is greater than b. And the formula for c is the same. The vertices now, we have h and k plus or minus a. Foci, h and k plus or minus c. So by this time, the order is being interchanged. For the major axis, equation is x equals h. Location is vertical. The length is the same, 2a. Endpoints h, k plus or minus a. Minor axis, equation y is equal to k. Location, horizontal. The length is the same, 2b. The endpoints of the minor axis or the co-vertices, we have h plus minus b and k. For the latus rectum equation, x is equal to k plus or minus c. Direction, horizontal. The length is 2b squared over a. The endpoints, we have h plus or minus b squared over a, k minus c, and h plus or minus b squared over a, k plus c. Eccentricity is the same, c over a, where e is between 0 and 1. Directrices equation, we have y is equal to k plus or minus a squared over c. So this is the graph of a vertical ellipse. The major axis now is parallel to the y-axis, and the minor axis is parallel to the x-axis. This is now the location of the vertex, focus, vertex, focus, vertex. Endpoints of the co-vertices, endpoints of the major. Endpoints of the minor axis, and they are the co-vertices. Endpoints of the major axis, and they are the vertices. You have the latus rectum, another latus rectum. You have the directrix, another directrix. Note, if a squared is the denominator of the square of x minus h, the major axis is horizontal. If a squared is the denominator of the square of y minus k, the major axis is vertical. Let us have an example. Find the coordinates of the foci and vertices, the endpoints of the major axis, minor axis, and the latus rectum, and the other parts and characteristics of the ellipse. Given the square of x minus 1 over 100 plus the square of y plus 1 over 36 equals 1. And give the general equation. So, these are now the results. The equation is the square of x minus 1 over 100 plus the square of y plus 1 over 36 is equal to 1, where a is greater than b. So, a squared here is 100, the value of a is 10. b squared is 36, the value of b is 6. And c is equal to 8. So, substituting a squared 100 and b squared 36, 100 minus 36 is 64. And the square root of 64 is 8. That is why c is 8. And the value of h here is 1. The value of k is negative 1 because this is y plus 1. So this is originally y minus negative 1. And the vertices, this is the formula. All you have to do is to substitute 1 plus minus 10, then k is negative 1. So we have the vertices 11, negative 1, and negative 9, negative 1. For the foci, this is the formula. Substitute. So we have now the first focus is 9 and negative 1. And the coordinates of focus 2, we have negative 7 and negative 1. For the major axis, y is equal to negative 1. The length is 20 units. The endpoints is 11, negative 1, and negative 9, negative 1, similar to the coordinates of the vertices, because the endpoints of the major axis are just simply the vertices. The equation of the minor axis is x is equal to 1. Location is vertical. The length is 12 units. The endpoints are 1, 5, and 1, 7. The length of the latus rectum is 7.2 units. To find the endpoints of the latera recta, all you have to do is to substitute the values to the formula. And the result now, we have 9 and 2.6 with 9, negative 4.6, and negative 7 with 2.6, negative 7 with negative 4.6. Eccentricity is 0.8. Equations of the directrices, we have x is equal to 13.25 and x is equal to negative 11.25. The general form, we have 36x squared plus 100y squared minus 72x plus 200y minus 3,464 equals 0. And this is the graph. There you have the center, 1, negative 1. The co-vertex, 1, 5, 1, negative 7. Here you have the focus, another focus, vertex, another vertex, endpoints of the latus rectum. And you have the first directrix, the second directrix. And to solve for the general form, given this equation, so you just simply multiply both sides by 3,600. So what we have, 3,600 by 100 is 36. 3,600 by 36 is 100. And expand. So we have 36 times the quantity x squared minus 2x plus 1. Expand the square of y plus 1. We have y squared plus 2y plus 1 equals 3,600. And apply distributive property, just simply distribute. You have now 36x squared coming from 36 times x squared, negative 72x for 36 times negative 2x, 36, that's 36 times 1. And here you have 100y squared, 200y, and 100. Copy 3,600. Simplify, we have 36x squared plus 100y squared minus 72x plus 200y plus 36 plus 100 minus 3,600. Then after equating to 0, you combine the like terms. So what we have is 36x squared plus 100y squared minus 72x plus 200y minus 3,464 equals 0. So this is now the general form. Next example. Find the coordinates of the foci, the vertices, the endpoints of the major axis and the minor axis, the latus rectum and other parts and characteristics of the ellipse, the square of x minus 3 over 9 plus the square of y minus 2 over 25 equals 1. So, the equation is the square of x minus 3 over 9, the square of y minus 2 over 25, where a is greater than b. So, this is the a squared part. So, a is equal to 5, b is equal to 3, c is equal to 4. Because the square root of 25 minus 9 is square root of 16, which is equal to 4. The value of h is 3, the value of k is 2. You have the vertices 3, 7. The other one is 3, negative 3. Foci 3, 6. The other is 3, negative 2. Major axis is x is equal to 3. The length is 10 units. The endpoints, we have 3, 7 and 3, negative 3. For the minor axis, the equation, we have y is equal to 2. The length is 6 units. Co-vertices for the endpoints of the minor axis, we have 6, 2 and 0, 2. For the latera recta equation, we have x equals 9 and x equals negative 7. The length is 3.6 units. The endpoints, we have 4.86, 4.8, negative 2, 1.26, 1.2, negative 2. Eccentricity is 0.8. Directrices, we have y is equal to negative 4.25 and y is equal to 8.25. And this is the graph. C, or the center with coordinates 3, 2. This is the focus, another focus, vertex, another vertex, co-vertex, another co-vertex. You have the latus rectum and the endpoints, the latus rectum and the endpoints, and you have the directrix, another directrix. And to solve for the general form of the equation of the circle using the given standard form, so all you have to do is to multiply by 225. And multiplying by 225 divided by 9 is 25. 225 divided by 25 is 9. And 1 times 225 is 225. Then square this. The square of x minus 3 is x squared minus 6x plus 9. The square of y minus 2 is y squared minus 4y plus 4 equals 225. Then distribute, you have 25x squared minus 150x plus 225 plus 9y squared minus 36y plus 36 equals 225. And then simplify 225, 36, and negative 225. So the general form is 25x squared plus 9y squared minus 150x minus 36y plus 36 is equal to 0. Let us have now the applications of ellipse. Example 1. The statuary hall in the Capitol building is a whispering chamber. Its dimensions are 46 feet wide by 96 feet long. What is the standard form of the equation of the ellipse representing the outline of the room? Your hint: assume a horizontal ellipse and let the center of the room be the point 0, 0. If two senators standing at the foci of this room can hear each other's whisper, how far apart are the senators? Round off your answer to the nearest foot. This is an image of a whispering chamber. And if this is the ellipse, Senator 1 is here and Senator 2 is here, will represent the foci. And the measure of the major axis is equivalent to 96 feet, and for the minor axis is 46 feet. So for the solution of the standard equation, we know that the length of the major axis is equivalent to 2a and is longer than the length of the minor axis, which is 2b. So the length of the room, 96 feet, is represented by the major axis, and the width of the room is 46 feet, which is represented by the minor axis. So to solve for a, we have 2a is equal to 96. Divide both sides by 2, so a is equal to 48. And a squared is equal to 2,304. And to solve for b, 2b is equal to 46. And divide by 2 each member of the equation, then we have b is equal to 23. So b squared is equal to 529. And we are assuming a horizontal ellipse with center 0, 0. So we need to find an equation of the form x squared over a squared plus y squared over b squared is equal to 1, where a is greater than b. So this is now the equation: x squared over a squared plus y squared over b squared equals 1. All you have to do is to substitute the value of a squared, which is 2,304, and also the value of b squared, which is 529. So the standard equation of the ellipse representing the outline of the room is x squared over 2,304 plus y squared over 529 equals 1. And for b, to find the distance between the senators, we must find the distance between the foci, which is positive or negative c, 0, where c is equal to the square root of a squared minus b squared. So for the solutions, all you have to do is to substitute 2,304 to a squared and 529 to b squared. And that is equivalent to 1,775. So the square root of 1,775 is equivalent to positive or negative 42.13. And since we're taking the distance of C, so we will use 42 feet since you are asked to round off. Since we're asked to round off to the nearest foot. So we only have 42 feet. So the points positive or negative 42, 0 represent the foci. Thus, the distance between the senators, that is equivalent to 2 times 42, is 84 feet. So this is the distance from the center to the focus represented by C. And this is equivalent to 42 feet. Example number 2. A portion of the White House lawn is called the ellipse. It is 1,060 feet long and 890 feet wide. Write an equation of the ellipse. The area of an ellipse is equivalent to pi AB. What is the area of the ellipse at the White House? This is the illustration. This is the lawn. And the measurement from here to here, which is equivalent to 2A, is 1,060 feet. And the measurement of here is 890 feet. This is the illustration in finding the area, which is equivalent to pi AB. So the measure from here to here is A, from here to here is B. Just simply multiply A and B with the pi and it will give you the area of the ellipse. So for the solutions, the major axis is 2A, which is horizontal. And the horizontal measurement is 1,060, equivalent to 2A. Divide this by 2, divide also the other side by 2. So A is equivalent to 560. And for the minor axis, which is 2B, that is vertical. So 2B is equal to 890. And divide this by 2, divide also the other side by 2. So B is equal to 890 over 2. So B is equal to 445. And the standard equation is x squared over a squared plus y squared over b squared equals 1. So all you have to do is to substitute. A is 530, B is 445. And this is the equation of the ellipse, x squared over 530 squared plus y squared over 445 squared equals 1. Or you can have x squared over 1060 plus y squared over 890 is equal to 1. And to find the area, we have the area is equal to A equals pi AB. So A, the value of A is 530 and the value of B is 445. And the result is approximately 740,944.63 square feet. So the area of the ellipse is 740,944.63 square feet. Do you have questions? If there is none, see you next time. Bye!